Welcome to the world of Internet Protocol version 6 addressing. In this module, we will be exploring the next generation Internet Protocol. Let's dive in. Let's explore the key motivations behind Internet Protocol version 6. First, it addresses the exhaustion of Internet Protocol version 4 addresses. Second, it offers a simplified header format. Third, it provides improved security features. Fourth, it supports better quality of service. And finally, it eliminates the need for network address translation or NAT. Now, let's compare the address spaces of Internet Protocol version 4 and Internet Protocol version 6. Internet Protocol version 4 provides 2 to the power of 32 addresses, which is approximately 4.3 billion addresses. In contrast, Internet Protocol version 6 offers a significantly larger address space, with 2 to the power of 128 addresses, which is approximately 340 undecillion addresses. That is a huge difference. Let's examine the structure of an Internet Protocol version 6 address. Here is an example of an Internet Protocol version 6 address: 2001:0db8:5a3:0000:0000:8 a 2e:0:370:7334. Each Internet Protocol version 6 address consists of 8 groups of 16 bits each, represented as 4 hexadecimal digits, separated by colons. These groups are called hextets. Each hextet contains 16 bits, and is represented by 4 hexadecimal digits, ranging from 0 to 9 and A to F. Internet Protocol version 6 addresses are case-insensitive, meaning that upper and lowercase letters can be used interchangeably. In total, an Internet Protocol version 6 address contains 128 bits. Let's explore the notation rules for Internet Protocol version 6 addresses. The first rule is leading zero suppression. In each 16-bit field, also known as a hextet, leading zeros can be omitted. For example, 0db8 becomes db8, and 0042 becomes 42. The second rule is zero compression. One or more consecutive groups of zeros can be replaced with a double colon. This can be done only once in an address. For example, 2001:db8:0:0:ff00:42:8329 can be compressed to 2001:db8:ff00:42:8329. It is important to note that the double colon can only be used once in an address. Let's explore some examples of Internet Protocol version 6 notation. Consider the original format of 2001:0db8:0000:ff00:0042:8329. The compressed format is 2001:db8:ff00:42:8329. This is because leading zeros are removed and consecutive zeros are compressed. Next, consider the original format of 2001:0db8:0000:0000:0ab9:c0 a 8:0102. The compressed format is 2001:db8:1:ab9:c0 a 8:102. Note that mixed case is allowed, such as C0A8. Let's delve into the special addresses in Internet Protocol version 6. First, we have the unspecified address, represented as : equivalent to 0:0:0:0:0:0:0:0:0. This address indicates the absence of an address. It is used by hosts that have not yet obtained their Internet Protocol version 6 address. This is similar to 0.0.0.0 in Internet Protocol version 4. Second, we have the loopback address, represented as : :1. Equivalent to 0:0:0:0:0:0:0:0:1. This address is used to identify the local host. A packet sent to this address will loop back to the same device. This is similar to 127.0.0.1 in Internet Protocol version 4. Third, we have the link local addresses, with a prefix of FE80::/10. These addresses are used for communication between devices on a single link or local network segment. They are not routable beyond the link. An example is FE80::1234:5678:9 Fourth, we have the unique local addresses, with a prefix of FC00::7. These addresses are used for local communications within a site or organization. They are not expected to be routable on the global internet. An example is FD12:3456:789, :1::/64. Global Unicast addresses are the Internet Protocol version 6 equivalent of public Internet Protocol version 4 addresses. They are globally routable and reachable on the Internet. The address prefix is 2000::3. The global routing prefix is 48 bits. This is assigned to organizations. Then the subnet identification is 16 bits. This is for subnetting. Lastly, the interface identification is 64 bits, and this identifies the interface on the subnet. Here is an example breakdown. 2001:0 DB8:0001:0002:020:5 EFF:5E00:7B. Internet Protocol version 4-mapped Internet Protocol version 6 addresses allow Internet Protocol version 6 nodes to communicate with Internet Protocol version 4 nodes during the transition period. They embed an Internet Protocol version 4 address within an Internet Protocol version 6 address format. There are 80 bits of zeros, 16 bits of ones, and a 32-bit Internet Protocol version 4 address. Consider an Internet Protocol version 4 address such as 192.168.1. The Internet Protocol version 4 mapped Internet Protocol version 6 address is :FFFF:192.168.1. The alternative hexadecimal notation is :FFFF:(C0) 8:0:101. And the full expanded notation is 0:0:0:0:0:FFFF:(C0) 8:0:101. Internet Protocol version 6 Multicast allows a single packet to be sent to multiple destinations simultaneously. All Internet Protocol version 6 Multicast addresses start with the prefix FF00::8. Here are some examples. For all nodes multicast, the address is FF02::1. This reaches all Internet Protocol version 6 nodes on the local link. For all routers multicast, the address is FF02::2. This reaches all Internet Protocol version 6 routers on the local link. For solicited node multicast, the address is FF02::1:FF00:0/104. This is used for neighbor discovery protocol. For dynamic host configuration protocol servers or relays, the address is FF02::1:2. This is all dynamic host configuration protocol servers and relays on the link. Let's summarize what we have learned about Internet Protocol version 6 addressing. Some key concepts are that it is a 128-bit address space which is 2 to the power of 128 addresses. There is hexadecimal notation with 8 groups of 16 bits. Leading zeros can be omitted in each group. Consecutive zero groups can be compressed with double colon. And there is no broadcast, rather it is replaced by multicast. Some address types are Global Unicast, which is 2000::3, Link Local, which is FE80::10, Unique Local, which is FC00::7, and Multicast, which is FF00::8. Some special addresses are the unspecified address, which is : the loopback address, which is : 1, and the Internet Protocol version 4-mapped, which is ::FFFF:192.168.1. Some benefits of using Internet Protocol version 6 are virtually unlimited address space, simplified header format, built-in security with Internet Protocol security, auto-configuration capabilities, and improved routing efficiency. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.